Hello everyone, welcome to Jazz Robotics. This is a video series for Jazz Robotics Sensor Kit. In this series, I am going to be covering 15 basic lessons. Very soon, I'll release video series for 50 plus Arduino projects that you can do yourself at home using Jazz Robotics Sensor Creativity Board. So please like, subscribe to the channel so you don't miss. To get most out of this series, I would recommend it to follow, and the links are in the description section of this video. Today we are going to be covering the first part of 15-part sensor kit series. The topic is pollution sensor with OLED. In this lesson, we'll go step by step and cover the following points. First, we'll start with a quick introduction to the project. Then we'll see the components required. After that, we'll understand the circuit diagram and wiring. Next, we'll walk through the Arduino code. We'll also run a simulation demo before moving to manual connections on a breadboard. Later, we'll implement the same project on sensor creativity board where all the connections are already provided. Finally, we'll test the complete working and conclude the project. Coming to the introduction, in this lesson, students will learn how to interface a pollution sensor with an OLED display using a microcontroller. MQ135 sensor is capable of detecting various gases, including ammonia, benzene, and smoke, making it a valuable tool for monitoring air quality. OLED display will be used to visually present the sensor readings. It is a flat panel display technology that uses organic compounds to emit lights. Now let's look at the components required to perform this experiment.
To perform this experiment, we need these components: breadboard, few jumper wires, Arduino Uno, USB cable, OLED display to visualize sensor data in a clear and readable format. MQ135 sensor. This sensor detects gases like ammonia, smoke and carbon dioxide, gives us an analog output that we can read with Arduino. MQ135 sensor has 4 pins: VCC, ground. VCC goes to 5 volts or 5 volts of Arduino, then ground to ground of Arduino. A0 is analog output. Arduino analog gives an analog voltage proportional to gas concentration. DO, Arduino digital pin, goes high or low when gas concentration crosses a present threshold. MQ135 module has a small adjustable knob, that is potentiometer, near the digital output pin. It allows us to set the digital threshold when gas concentration exceeds this level. DO pin goes high.
After gathering all the required components, now let's look at the wiring and circuit diagram. First, connect the MQ135 sensor. Connect VCC pin of MQ135 to 5 volts of Arduino. Ground to the ground of Arduino. A out of the MQ135 to unlock pin A0 on the Arduino. This connection allows Arduino to read and log air quality from the sensor. Then let's connect the OLED display. Connect VCC of OLED to 5 volts of Arduino. Ground to the ground of Arduino. SCL pin to A5 on the Arduino. SDA pin to A4 on the Arduino. Before powering up, double check all your connections. Once confirmed, connect your Arduino to your computer or battery. Now we will go through the code step by step. Here, this library handles I2C communication between Arduino and OLED display. This library provides basic graphic functions like printing text or drawing shapes. This is the specific driver library for our OLED display module. Then we define display parameters. This means our OLED has a resolution of 128 by 64 pixels. This tells Arduino to communicate with OLED over I2C. Here the sensor A out pin is connected to A0. Then we'll use this to measure air quality. Then coming to the setup function. Inside the setup function, we first start serial communication. This allows to print readings on serial monitor. Now we initialize the OLED display at the address of 0 by 3C. If initialization fails, the code will stop running to prevent further errors. Once the display is ready, we print a welcome message AQ135 air quality, just to show that setup was successful. Then coming to the loop function, this is where the real-time monitoring happens. First we read the analog value from the sensor. This value ranges from 0 to 1023 depending on the gas concentration in the air. If the value is less than or equal to 300, the air is considered good. If the value is between 300 to 600, it's moderate. Above 600, it is poor. We then print both sensor value and air quality status on the serial monitor. After that, we clear the display and print all the information neatly on the screen. Title MQ135, air quality at the top, current sensor value in the middle, air quality status good, moderate or poor in the bottom. This makes us easy to visualize air quality changes instantly without needing a computer. Finally, there is a 1 second delay before updating the readings again. Now we will start a simulation demo of MQ135 air quality monitor with OLED display. First, let's look at the connections between the components. Here we are using mainly three components: Arduino Uno as a microcontroller, MQ135 gas sensor for measuring air quality, OLED display for showing readings. Here are the connections. MQ135 sensor VCC is connected to the VCC 5 volts of Arduino. Ground is connected to the ground of Arduino. Then A out pin is connected to the A0 analog pin. Then OLED display VCC is connected to the 5 volt. Ground of OLED is connected to the ground of Arduino. SCK of OLED is connected to the A5 pin of Arduino. SDA of OLED is connected to the A4 of Arduino. These two components use analog and I2C communication, making wiring simple and clean. After this, we will upload the code. Once wiring is done, we upload the same code as we have discussed earlier. In this, they includes libraries of OLED display, basic settings like screen size, reset pin, analog input, MQ135 sensor, setup function and loop functions. Once we start the simulation, here as you can see, title MQ135 air quality monitor. We can change the readings of the sensor. Same will be appeared on the OLED display and console window as well. Air quality is moderate, sensor value is 512. If we change it again, it will show as per the readings. Status is poor, air quality is 130, 813. Now status is good. As you can see, the same readings are getting displayed on OLED and console window as well. So by this, we have successfully connected and simulated MQ135 gas sensor with OLED display. We read analog values, processed them into air qualities. This simulation helps us understand how sensors communicate with displays in real-time monitoring system.
Now let's look at the manual connections for this experiment. I have given wiring as per the wiring diagram. VCC pin of MQ135 sensor to 5 volts of Arduino, ground pin to ground, A out pin to the A0 of the Arduino, OLED, SDA to A4, SCL to A5, VCC to 5 volts and ground to the ground of Arduino. Next we'll upload the code and let's see what happens on OLED screen. As soon as we upload the code, you can see on OLED display it is showing the sensor value and status. Air quality status is good. Value is 74, 71. It is changing. In clean air, readings usually stay between 150 to 300. If we bring the sensor close to fumes or smoke, the value gently increases and showing poor air quality. So in this demo, we learned how to connect MQ135 manually, how to read its analog values on the serial monitor, and how readings change with air quality. In this demo, we are going to perform air quality monitoring experiment using the MQ135 gas sensor and OLED display on sensor creativity board. We'll connect the sensor, run Arduino code, observe the readings on OLED and serial monitor. First step is sensor setup on board. As you can see, Arduino is already inserted in the sensor creativity board. Now we will insert the OLED at its slot. Make sure we are connecting it to the correct pins. Then insert the MQ135 sensor. This will upload the code using USB. Once the code is uploaded, as you can see on OLED screen, we can see the title MQ135, air quality, current sensor value and status of the sensor. The values keeps on changing depending on the air quality, as well as the status also changes. On the serial monitor, same data is printed continuously every second.
Now let's look at the serial monitor in Arduino. As soon as Arduino powers up and code runs, we will see a message like starting MQ135 plus OLED air quality monitor. This tells us that board and display have initialized properly and experiment is ready to run. After that, OLED initialized successfully. It started giving sensor values, air quality status. Sensor value is raw analog reading from 0 to 1023. Air quality status is a qualitative interpretation, good, moderate, poor, based on sensor value. The console keeps updating these values every second. As the air quality changes, the status dynamically updates. This helps students or viewers see the effect of different environmental conditions on sensor output in real time. Like if there is a low value, indicate cleaner air. Uh, like it is the low value, so the air quality status is good. Medium values indicate moderate pollution. Here we will get medium when we have moderate pollution. High value indicate poor quality. The console output acts as a debugging tool and confirms sensor and code are working correctly before looking at OLED display. Now let's summarize what we learned from this experiment. First, we learned how to use MQ135 gas sensor to measure air quality. We successfully interfaced the sensor with OLED display to visualize real-time readings. This experiment helped us understand analog signal processing and how to interpret air quality thresholds. We conducted the same experiment on simulation software, manual wiring, and also sensor creativity board. Across all setups, outputs were consistent, which shows that our connections and code was correct. This activity built a foundation for more advanced environmental monitoring projects. And finally, using the sensor creativity board made the demo cleaner, faster, larger, and error free. Thank you for watching.